Okay, so we're going to talk tonight about being quiet. And if I can remember how to do this. Okay, so the first thing is, what is SSH? It stands for Secure Shell. That's the letters that come in here. It is a tool used to create remote connections to other computers. It's really important for sysadmins because we're taking care of machines all over the place. Some important features for SSH. It's secure, hence the secure part of the name. Authenticated, so you have to authenticate, log in. It's encrypted. Again, that's part of security. And then it is interactive as we use it, but it doesn't have to be interactive. But it's important that we can be interactive on the other system. Here's a simple example. So the things on the left are the prompt for a computer. If you're familiar with a shell, you're already familiar with that. So SSH, give it a host name. It'll ask me for a password. Now, important for that, which password is it asking me for? So my password on the other computer. If I'm logging into somebody else, right? If this was part of one of Aaron's classes where I'm like, hey, I'm logging in as this other guy so I can take advantage of the computer. I'm logging in with their password, right? So you're logging in with the password for the account on the remote system, and presuming of course you get that correct, you get a prompt, you get a shell on the remote system. That's what the default is. We'll cover non-default later on. But so by default, you get a shell, and that's what I say about an interactive. Now I have a shell command line on the other system, and I can do all the things on that system that I can do from the shell, just like I can on my local system. Again, also dependent on permissions and so forth. If I'm logged in as me on the other system, I do not automatically have root privileges. I need to have the ability to sudo or su on the other system in order to get those, or have a vulnerability that I can use to break into it. Again, come to the Tuesday class for that portion of the information. All right, and that arrow still does not work. All right. Now, it's an important part, and this is actually I find this does not get covered very much for when we talk about SSH. When you connect to the other computer, you're not just connecting. So, like if you pull up a web page, http www.example.com, right, with some other syntax in there. You go and say, hey, give me this information, and the computer gives you information. Your browser goes through and displays it. But if you use HTTPS, there's a protocol that's going on in place to go through and negotiate a secure connection and verify that that connection is secure, but also that web server is who that web server claims to be, using a third-party certificate authority. SSH does not have a third-party certificate authority, so you have to go through and verify that on your own, and by default, it shows you the keys. So for HTTPS, you kind of actually have to go out of your way to go find the keys and look at the fingerprints and do all that if you want to go do personal verification. For SSH, it's up front. Yay, here's the key for the server you've never talked to before. Don't just accept that key. We'll get to that again later on too. So that's an important part of that connection is you want to verify which machine you're talking to. So we're using the public key encryption, and that public key portion, so I back up on that. Public key encryption means that you have two different keys. One is public, one is private. The public key can be posted anywhere. Put it on a billboard, right? If you've got a machine that's connected to the internet that allows anybody to connect to your SSH, which is usually in port 22, then anybody in the world can connect it to port 22 and get your public key, because that's your server says, hey, here's my name, and gives you the public key, right? So that can be as public as you want. If you, like I said, if you want to pay for a billboard, put it on a billboard. If you want to put it in your signature, put it in your signature in your email. It's a little verbose for that, but you can do that. Now, the private key that the server uses, and we'll get more into this in a future topic, a future night, but the private key, that you have to keep safe. Because anybody that has that private key can now impersonate your server. Because that's what's used to go through and decrypt the information that you sent for the initial connection, right? So keep the private key safe. It should be readable by root only on your system. If you can lock it down even more than that, that's awesome. But don't let other people have it. Don't put it on multiple machines, things like that. Keep the private key safe. It is by default. Keep it secret. Keep it safe. Yes?
The best place to put it would be if you're doing DNSSEC SSH will check DNSSEC and won't bother you with that nagging question of whether you trust the computer that you're going to. It authenticates it through DNSSEC, and then without any interactivity, we'll go ahead and do your SSH session.
So his point is that you can put it in a DNSSEC, which we'll get to in a couple slides if I remember which arrow works. But you put it in a DNSSEC, and he actually gave more information than what I'm going to say about how the DNSSEC works and does the authentication for you. But keep your secret, your private key secret, and keep it safe. Don't let other people get a copy of it. All right. So the public and private key do one-way encryption. So the private key can decrypt data that was encrypted with the public key, which is why you can take the public key, you can encrypt something with it and send it to the server and be certain that only that server can decrypt it. Right? Or only those people that have a copy of the private key, which should only be the server. Public key can the public key can decrypt data encrypted by the private key. So if the server encrypts something with the private key, you can decrypt it with the public key and verify that it came from the server. You've got a way of verifying where it came from because it's been signed. Right? That's the main thing we do with signing. But they cannot decrypt information that they encrypted. So if the private key encrypts data, it can't decrypt that data. If the public key encrypts data, it can't decrypt that data. They have to go to the other one. So it's not like the jumbles in the newspaper where you figure out what the key is and it works both ways. So, and it's not, it's not the same as our favorite encryption protocol, which is ROT13. So, all right. SSH server keys. So again, the server displays the public key. You use that to verify you're talking to the correct server. And this is something that you need to do. We'll talk a little bit more about that in a second. The server private key, keep it secret, keep it safe, and avoid using for multiple servers. So I know of some places that go through and they've got a build process where it builds out the server and they don't change the public key. So every server in their environment gets the same public key, which is kind of convenient because you only need one key to check. But now every machine has that, and any machine that gets broken into basically gives you access to every machine in your environment because they have the private key. And it also allows somebody that breaks in to go through and impersonate every machine in your environment because they have the private key. So each server should have its own unique private key. Well, key pair. So yes, you're right. So it should have both a unique private key and a unique public key that go together. So it should have a full key pair. You're right. Having only unique private key but not a unique public key would kind of not work so well. So I don't know. I was listening to Stick, so I put Kilray in here. But be careful of the man in the middle. Somebody's looking over. The man in the middle is basically, I'll get to that in a second. So verify your SSH keys before accepting them. If you connect to a new box, don't just accept that key. Go through another way of checking that SSH key. Blindly accepting keys can open you to a man-in-the-middle attack, including on your internal network. Right? If somebody's already gotten into your internal network, they can start impersonating other machines. And if they don't have the private key, then they can't really impersonate it. But if you're just accepting keys, then you'll never know, or you might never know. For a man-in-the-middle attack, the attacker pretends to be the destination server. So it says, hey, I'm your web server when you try to connect up. And any router along the way can do that. Any router along the way, any switch along the way can go through and divert traffic. So that's, depending on how far you're going for your connection, how many ISPs you're going through, how many different backbone providers you're going through. There's a lot of places where somebody can pretend to be your server. And including in your internal network, you're still probably talking to multiple routers along the way. If somebody can compromise one of those routers, they can start impersonating machines, unless you're going through and verifying your SSH keys, your host keys. So if you accept that key without having verified it, that person can now, man in the middle, stand in the middle of your conversation with the server you want to talk to and read all of your data as it goes back and forth, including all of your authentication credentials and things like that. So we really don't want it to make that easy for them because it is really, really easy to go through and impersonate a system, depending on where in the network they are. Right? So always verify your SSH host keys before accepting them. There are so many web pages. Oh my gosh. I think that there's more web pages about turning off strict host key checking for SSH than any other topic in SSH. We're like, oh, just turn it off and never be bothered with this again. That's like saying, hey, don't bother to check that it's your house key that's being used on your door. Just let any key work, right? It's just a really bad idea. Do not set that on, turn that on. And some of them are even really good technical sites where I see that as an answer all the time. And I should put the XKCD about, I can't go to sleep because somebody on the internet is wrong. That one topic could keep me up nights for years, just going through and posting about that. Verifying host keys is not near as annoying as having somebody break into your network and break into your systems, right? If somebody owns a bunch of your servers, that's going to be much more of a nightmare and much more of a burden undoing that than it is to go through and check host keys. There's some fairly easy ways to do that. On your own systems, it's fairly easy because you control them. On systems that you don't, or that are for work or something like that, it's a matter of putting up the right environment. But it's the same thing. If you're just randomly downloading ISOs from strange places and installing them and using those for your production systems, you've already failed, right? You should go, hey, I'll go get the cracked Debian.ru and try that one on all my production systems. Well, that just seems like a bad idea. So you want to make sure you've got good policies in place and a good build process in place. And if you do, you'll be collecting those keys as you deploy new systems, and you can then put those keys in place. And we'll get to that in a second. So always verify host keys. And as Ed pointed out, that doesn't mean I have to go look at them all by hand. There's automated ways of doing that. We'll get there. And again, disabling strict host keys is just a bad idea. It really opens it up to man-in-the-middle attacks, including inside your internal network. And in an example, at a place I work right now, there is a domain that is similar to our domain that's out somewhere in Hong Kong, shall we say, that has put up a bunch of hosts that are the same as ours. So you've got webserver.fakedomain.com, right? And it's a typo from our domain. And the way I found out about it is I typoed one day, and I got a key that did not match for a server I talk to all the time. I'm like, that server should not have changed. And it turns out it was because it was another machine. I was talking to somebody in Hong Kong. And if I'd have just said OK and accepted that key, that remote server in Hong Kong would have had my credentials, would have had my user ID and my password. Luckily for me, in this particular case, that password is only used for internal systems, so it wouldn't have done them any good until they get inside my network elsewhere. But still, I'd rather they don't have my password. So it's good to always verify your keys and make sure your client is set up to make sure you're talking to the machine you think you're talking to. So SSH host key verification. The client presents you with a fingerprint. So the server gives your client a key. Your client then makes a fingerprint of that. The fingerprint is a hash value derived from the public key. So does anybody not know what a hash is?
It's an important point, Stu.
It's a chili pepper.
Yes.
No, that's a hatch. So the answer was a chili pepper. So a hash is a one-way digest of data. So you can't take the fingerprint and reverse engineer it back to the original key. And the key, one of the other pieces here, and that's key for us, is it's unique or relatively unique. The mathematicians in the world can go into what's really about the uniqueness, and the security guys have a little bit higher thing than requirements than the rest of us. But for us, for our intents and purposes, it's a unique representation of that key. So you get that at the client level, and depending on how you've got your client set up and whether or not you've talked to that server before, your client will then go, here's this fingerprint. We'll get to that in a second. So some ways that you can do the key verification. You can make a copy of the fingerprint before connecting via SSH. So if you've already got a copy of the fingerprint, then you can compare that the new fingerprint matches the one that's known to be good. Right? When somebody gives you a phone call and says, hey, this is your friend Fred, you check and say, does that match Fred's voice? If it doesn't match Fred's voice, then you're like, you don't sound like Fred. Why are you claiming to be Fred? Same type of thing. You're checking that fingerprint. You can hop on, if you don't have the fingerprint already, you can hop on the console depending on where you're at. If you're at home, you can go log in on the box itself and go grab the fingerprint. If you're doing something for work, you might be able to get on the console via a remote connection, and you can grab the fingerprint from the console. There is no internet connection between the console and the machine, so you can be fairly certain that it's not being that's not being spoofed, provided you've got a secure connection to the console to begin with. But that's beyond the scope of this presentation. You can have a local admin read you the fingerprint. So if I am logging into Brian's system, I can call Brian and say, hey, what's the fingerprint for your system? And give that to me, right? And I can then do verification. And then, of course, I can also look at, I can also look in known hosts, which is where the SSH client stores fingerprints it knows about, and say, have I talked to this machine before? Because perhaps the machine has changed IPs or changed names or something like that. So you might actually have a copy of that key, that fingerprint inside your known host files already. And then you can, like I said, it's public. So you could also tattoo it to your hand, right? Say, hey, I just set up this new system, and take it over to the tattoo artist and say, okay, read that line and put it right here. So when I log in, I can verify. It's public. It doesn't matter that other people can see it, that it shows up in all your selfies from now on. I don't know how you selfie your hand, but whatever. And then a key point, I'll get to you in a second, Ed, is to use the full fingerprint. I did not know until recently, but there's apparently some half fingerprint you can use, and people have been using that. Don't do that. A few years ago, that might have been worthwhile, but nowadays, make sure you're using the full fingerprint because you need that those extra bits for verification. Yes, Ed?
When you deploy the system, you can update the hash in DNSSEC so that when you shell into that new system for the first time, yeah, exactly, that slide.
So again, Ed's getting more in detail, but that's fine. So the second line is SSHFP. So SSH fingerprint is a data type for DNS, and you can put that into DNSSEC. And what Ed is saying is that you can, when you set up a new system, you can have it automatically go through and put the new key into DNSSEC for you, so you've automatically got that key out there for you to grab, for your system to grab. And as he pointed out earlier, your client can be set up to go look in DNSSEC for verification, and then that takes care of that verification for you behind the scenes, so you don't have to do the manual verification. So for me, this is again for publicizing things. You can put it on a secure web page. That doesn't. Now, key for me to make this secure is it doesn't use JavaScript, because JavaScript can do a bunch of things to try to lie to you. So making it as plain text as possible, so plain HTML or plain text is even better to me. It reduces the chance that somebody can be doing malicious or manipulating things. But if it's on a secure web page, you're taking advantage of that third-party security that I was talking about earlier that websites have. So that page should be secure. And again, depending on how well you protect the third party and or trust the third party. But you can then put all of your SSH keys on a web page, and you can be able to grab them there. If you have set up DNSSEC, which is not very common at this point, lots of people have web pages and websites, and through Let's Encrypt, we can all have secure websites. If you haven't done that, please do. Let's Encrypt is awesome. It doesn't cost you anything but a little bit of time, a little bit of effort, and it was really, really easy. So everybody can have a secure website at this point. So everybody has that. It's a fairly low barrier to entry. DNSSEC is not as common at this point, but as Ed pointed out, you can use it. Sounds like a great tool. I don't have personal experience with it yet to talk about how good it is, but I know of other people using it that are happy with it, and the people who worked on it understand security better than I do, so it should be secure.
It gets rid of that interactive part.
Well, the interactive check, yes. I have scripts for that. All right, you can snag it during the deploy process. So when you install a new machine, grab a copy of it, and then you can put it on a text file in your local system. You can add it to your known host by hand already when you do that. And then you can also snag it from orchestration, such as Puppet, Chef, Ansible. Anthony isn't here. I put Terraform in there just for him. All right. So you can grab it from everything else there. The key is a lot of this is trying to make it, the scalable part is to make it automated so that you don't have to be doing this by hand. You can go through and grab a whole bunch of them. So at one point, I changed jobs to a company that wasn't doing any SSH key maintenance at all, which would be pretty well every time I've changed jobs. But this one time, I won't talk about, I wasn't doing anything, but they were doing most of their system deployments and most of their orchestration via Puppet. So I went through and wrote a script that grabs everything from Puppet. So every time Puppet grabs information from all the servers that it talks to, one of the things it grabs is the SSH, the host public key. So I grab them all out of Puppet, and I create a known host file for that out of Puppet. I check to see if it's changed. So we had this one machine that's somebody's personal system, VM, that keeps changing every time, and they just have a process that goes through and rebuilds the machine every half hour for some reason. So I also know that if any of my web servers, any of my admin servers, cron servers, etc., have a new key, because they shouldn't have a new key, especially the ones that have been up for 4 years. That would allowed me to pull all those in. I put them into a known host file. On newer versions of SSH, which is the last 3 or 4 years, I can declare multiple known host files. So in this particular case, we actually had 3 different Puppet servers. So I have 4 known host files. 4, not that. One is mine, so my normal known host file. And then I have one for each of the 3 Puppet servers, which are basically serving different companies. And that way, when I talk to SSH to web server for company A, I can check it'll look in the known host files, and but I don't have to merge those 3 different known host files together. I can do them all separate, which is awesome. On older versions of SSH, you have to merge them, and that's a pain. But you can do that. And it made it really easy for me to go grab all that information. I don't have to work with whoever's doing our deploy process. We've already got whatever we want to have in place to get it there. Once it's on the network in a place that I care about, I have the SSH key through a secure third-party mechanism, so I can verify that when I connect up. So let me introduce a fingerprint. This is a fingerprint. SHA-256, whatever all that stuff is. Well, it does say Russian there, so it's awesome. All right, so that is a sample fingerprint. It's pretty easy to memorize, right? So you don't need to tattoo it on your hand. You can just memorize that, right? You can visual diff it. So look at it here, see if they're the same. Or back in the day, you just print them out and hold them up back to back and see if they're the same. But in the end, handcrafted artisan key verification is slow and error prone, right? It's hard to go through and look at this and make sure you don't make any mistakes. It takes a while to do that. And if you're connecting to potentially thousands of machines, like I am for work, that becomes a large part of your day, because I can be talking to machines that I've never heard of before, and suddenly I need to go fix them because they broke. So instead, one, I build the known host file so I don't have to worry about all this, and I already have it. But in the case that I can't do that for some reason, for instance, I'm using a really, really old Red Hat box that just has an old version of or CentOS in this case, a really old version of SSH, then I have to go through and do some stuff manually. So I can SSH in, it gives me the fingerprint. I can then copy and paste that and grep my known, pull all the fingerprints out of known hosts and grep for it, or whatever file I have these in, which includes going and grabbing them from a web page, going and grabbing them from DNSSEC, wherever I would get that, and I can then verify, because grep will make sure that they're the same. Right? It does that comparison for me, and it is far less error prone than I am. Far less error prone than I am. And when I start talking in a future presentation about tunnels, this becomes even more important, because what the machine claims to be, it could be different depending on how I'm connecting to it. And it should be. And just because we should have there's an ASCII Puffy. Puffy is the OpenBSD mascot. OpenBSD project is who gives us OpenSSH. the SSH we should be using. So, and I do everything in plain text as much as possible. So I used an ASCII Puffy. All right. So making an SSH connection. And like I did before, SSH, give it a host name. That host, provided we've gone through and verified a key before, will then prompt me for a password by default. There's some other things we can do. We'll cover in other presentations. If I authenticate properly, I get a shell on the remote machine, just like the example early on in the presentation. I did not give an example of what happens if you're getting a key for verification or fingerprint for verification. So I wanted to show that here. I guess I did the previous slide now. So it says, hey, I don't know who this is. I can't check the authenticity of this host, and gives you information about the host. So here's the host name. Here's the host IP address. I can't verify this is the one you're trying to talk to. Here's the key. Would you like to connect? Yes or no? And you can actually configure this to do different things. This is the default. I really highly recommend leaving it to default so you get these types of prompts when you connect to a new machine. And then it's up to you to go through and do that verification. If you just blindly say yes, you have no idea if that machine is the one you want to talk to. No idea whatsoever. And you can go through and say, oh, okay, but I'll check the key on that system when I get on there. But again, if I'm doing a man in the middle, I can be changing the data that you're getting. When you say, hey, show me the host key on the remote system, because I'm a man in the middle, I can be watching for that and be changing that information as it comes back to you. Right? So I can do, there's a lot of things I can do if I'm in the, actually I can do anything as a man in the middle, provided I've got the programming know-how to do so. Right? Now I can also just run a remote command. So by default, you get a shell, whatever your default shell is on that remote machine. So if you have bash on your local machine as your default shell, and ZSH is your remote shell on the remote machine, then on the remote machine you'll get a ZSH shell. Because whatever your environment is on that remote machine is what you'll get, because you're logging into that remote machine, and you get whatever is in that environment. But if you instead give it a command, so the host name command in this particular case, so I SSH to Cygnus X1 again. I say give it my password and authenticate, and then now the SSH server says, oh, you just want to run this command. It'll run the command, give me the output if there's any output, and then kill the connection. So by default, you run a shell, and it does the same exact thing. When that shell is done, when you type exit and that command is over, it just happens to be a shell that does multiple commands. When that command is over, the connection gets closed. So the same thing. If I give it a command that just says, go do this one thing and be done, then the connection's over. So in this case, gave me the host name of the remote machine, and then I come back to a prompt back on my local machine, because it ran the command and exited. I can also do that with a more complex command, which is what the next example is. In this case, I'm saying run top, run it once, -n is number of times, so I'm saying 1. And then I pipe that to head -4. Head -4 says just give me the first 4 lines. The reason is because I don't have room in the presentation for a full output from top, plus we don't need it. And I had to put this in quotes so that the whole thing would run on the remote machine. But I have an extra option in here, which is the -t. And the -t says give me a TTY. So top is an interactive command, and it wants to have a TTY like you've logged in. In this particular case, I'm not actually creating a shell and getting a TTY and going through all that. So without the -t, it'll just give me an error about, hey, I can't find a terminal and not give me any data. So I have to use the -t in order to get that. If you were, for instance, logging in to edit a file, so you're SSH remote host and Vim a file or Emacs a file or whatever you want to do, then again, you'll need to give it the -t to say, hey, pretend I'm actually on a local shell and do stuff. But when you finish that editor, you'll be back on your local machine again.
So is there a time that you cannot use, you don't have to use the -t?
If you're not running an interactive command. So the host name, I'm just saying, go give me this information. If I'm, actually, well, not interactive, a command that wants a terminal. So, for instance, if I was changing my password on the remote machine, I probably don't need the -T. I haven't tried that recently, so I don't remember. But anything that wants like I say, a terminal will want that. But there are lots of commands, including some interactive commands.
It's an underlying shell to kind of.
Well, it's more of like you would run in an X term, right? So something that wants an X term, essentially. But most commands don't need that. However, if you run a command and you get an error about no terminal, the -T is the way to fix it. All right. So as I mentioned, this is part of a series I'm doing for an online magazine, or tech journal, I guess. So future topics will include SSH tunnels, SSH tunnel acrobatics. We'll get into that. SSH configuration and command line tips, and then keys, agents, and pipes, along with lots of bad jokes about Clue. All right. And some resources. Of course, the OpenSSH site. I wrote an article for Linux Journal a number of years ago about tunnels, so you can get a preview of the next presentation. Actually, I think you can get a preview of the next two presentations, kind of. And then I also have a link with an extra square bracket to my talks. So this talk will be up there along with previous talks that I've done elsewhere. Do we have any questions? Yes, Ed.
I think you can run a command on your machine, like VI, and have it shell through to another machine and edit a file on that other machine.
Yeah.
And if you're just editing, that may or may not be all that exciting. But if you're, for example, doing a rootkit scan or mtree that checks all the hashes of the binaries that if you're doing an integrity check on the system, you can do that from a remote machine and check the integrity of the binaries on your target machine without having to run a command on that target machine.
You're still going to need to run a command on the target machine to some extent, or at least get data from it, obviously. Yeah.
If you can shell into it, you can then check all the hashes of the binaries in bin and sbin and confirm that they haven't changed. Running the application from your third.
You get chicken and egg things there with that, because if I've broken into your system and changed the libc on you, and I changed ls or whatever, I can have included in my version of libc an override that does, when you do a checksum of ls or a checksum of libc, that it automatically gives you the old version of it.
Well, all the checksums occur on your remote machine, but of the target files on the server.
Yeah. So, but in that case, you're copying everything over and then doing the check. So you're basically making a remote copy of the file system and then doing the checks. Yeah. So there's some things that, but your initial point that from a editor you can remote into another machine for editing, for anything else. So VI and Emacs will both give you a shell from which that you can do anything. They also both have built-in, although I think for Vim you have to add a tool to do it, but they both have essentially built-in mechanisms to remote edit. I'm pretty certain that Emacs can remote edit at the molecular level built in. You just have to be able to know the right key combinations for it. But yeah, so lots of other tools use or take advantage of SSH remote connections. I'll get to that in a future presentation about for instance, doing backups instead of telnetting to the other machine and copying all your data in clear over the internet. You can use a secure connection to do that.
So you could use an application that you have on your workstation on another machine that it's not installed on. So if you have a backup application, you could do all of the execution occurs on your machine through a shell, an SSH connection to a target machine. So.
Yeah, to some extent. In that you can basically set up SSHFS, which makes the remote SSHFS is SSH file system that basically presents the remote file system as a file system on your local computer. So then anything you can do on your local file system, you can do on that, just with added network and encryption slowness. It's useful, but it also has some limitations.
Back in the day, we used it to run make on a system that in production wouldn't have a development environment, wouldn't have a compiler.
Mm-hmm.
But you could do the compiling, on a machine that's not exposed, and have it just do all of its deployment.
I've certainly done a few things like that over the years. I don't use SSH for FS very often, but there are definitely some times I've taken advantage of that, or taken advantage of pulling data across and doing things on it and putting it back, or pulling data across and doing checks on it. It's not as fast as doing it locally in most cases, although if your remote system is a rather really slow CPU and some other things, or as Ed was talking about for security reasons, there are some times when you want to do that. So the nice thing is it's just a remote pipe. You can do anything you can figure out how to do. Yes?
Two quick questions. One, personal preference whenever I set up a system with SSH. I go in and I change the setting, permit root login equals no. That's just me, but I'm curious.
It shouldn't be just you. It should be everybody. So just so we get this for the microphone, so the suggestion from the audience is to put permit root login equals no. Yes, everybody should get that. I believe that's in presentation 4.
Other quick question. I've gotten used to a tool called Synergy, which allows me to use the same keyboard and mouse on one system across the others. And the default version of that does not encrypt traffic. I tunneled it through SSH. It's just, I'm paranoid.
Yeah.
For those of you that are using it, do you do that or not?
I haven't used Synergy in
A decade, no, not quite a decade. Actually, no, I think like 15 years. Been a while. But when I did exactly that for the same reason. But that problem was it was a unique work environment, shall we say, in a lot of ways. And I was using Synergy, a KVM, and something else. And it got to where it was just like, I didn't know how to get where I was going because all the bases looked the same. And so I had to stop using it. But it was a great tool that really helped me in a particular case then. But yes, for Synergy and other tools I use that are like that don't have SSH built in or security encryption built in, I go through and do them over SSH. And we'll get into doing graphical applications over SSH and when I think that's the tunnel acrobatics presentation. It might be the next one. Not this. All right. Any other questions or comments? Aaron's figured out 3 ways to break my SSH environment. Okay. Well, thank you very much, and we'll see the next topic next time.